So these tipping points in the Earth system, there is a school of thought, especially in Europe, which is very strong proponent of the tipping points and the urgency of watching out for these and how they may happen faster than we anticipated. But actually, in the current crop of climate models, it's not very easy to predict or even estimate the time at which these will happen. So indirect evidences and heuristic arguments are used for those, but when we talk about past climates, obviously there have been scenarios where Greenland ice sheet was non-existent, Arctic was warm and there was no sea ice, Antarctica had no glaciers, and so on and so forth. So the climate system does have solutions where we tip these over into a loss. And we must remember in any case that the loss of ice sheets is not going to recover very fast. Those happen on very slow time scales, but the melting phase can be very fast. So this is estimates going from 1 to 3 degrees C warming, 3 to 5 degrees C warming, and greater than 5 degrees C warming. And you can see which ones are likely to tip over. Okay? Why do we have to watch out for those? Already the Arctic warming and the reduction in the extent of ice, for example sea ice, is argued to affect the jet stream, which is like a referee between cold Arctic polar air and warm subtropical air, and the Arctic warming is argued to increase the wobble in the jet stream that we will look at a little bit later on, which means warm subtropical air can rush to very high latitudes and do serious damage to Greenland glaciers and snow and ice on continents, and of course Arctic sea ice. And very, very cold air can rush down into regions like DC and create minus 50 degrees centigrade, and people can say, where is the global warming? This is feeling cold like Mars. But when you have minus 50 degrees over DC, you can have 60 degrees over Alaska, which is incredibly warm, or very warm temperatures over Europe like Belgium. Okay, that was happening this year, in fact. Okay, jet stream, that's the relation between the Arctic summer ice and jet stream, and there is also a relation to Greenland ice sheet in terms of warm air. Boreal forests, they may have a tipping point. If they disappear, there could be large changes in the climate as well as carbon sources to the atmosphere. West Antarctic ice sheet and East Antarctic ice sheet, this one is more stable, requires larger warming, but uncertainties are high. This one is showing some instabilities, and the Southern Ocean makes this story a bit complicated, as we talked about before. But again, the thing to remember is that the glaciers, if they are lost, it's not going to be recovering anytime soon. Amazon rainforest, if it collapses, does it have a tipping point? Thermohaline circulation. In the past, we talked about how the Younger Dryas was caused by rapid changes in the thermohaline circulation because of freshwater release. For example, if you remember the movie Day After Tomorrow, they are reporting very, very warm temperatures up here in Greenland in the ocean, and before you know it, the hero and his girlfriend are sitting in a library in New York that is frozen over. So if you have very warm temperatures here, and Greenland glacier potentially puts a lot of fresh water onto these deep water forming sites over Labrador Sea and the Greenland, Iceland, Norwegian Sea, then you could change. The Gulf Stream is not going to disappear because it's related to the rotation of the Earth and change in Coriolis with latitude, increasing Coriolis effect with latitude. But the amount of heat to be carried from the tropics to these latitudes can change a lot. And if you put fresh water here, same amount of evaporation and same amount of salt left behind would not produce deep water because you have put a lot of fresh water from, let's say, Greenland ice sheet. and this has happened also 8,250 years ago, where there is a little blip of half a degree in the paleo records, which is potentially related to hiccup in the thermohaline circulation. But none of the models right now seem to indicate that thermohaline circulation is going to change dramatically with these warmings. Okay, permafrost, obviously frozen soil, stores a lot of carbon and methane, but the story has turned out to be complicated as well, because thawing of the permafrost is creating some lakes on the surface, which is producing photosynthesis and taking up carbon. So again, potentially there is a tipping point, but not clear. Uncertainty is high. Coral reefs, large parts of the Great Barrier Reef are not recovering because they are used to getting bleached by El Nino and La Nina, but global warming on top can tip them over. Are they in danger of collapsing? We don't know, because there are some corals up here in the Red Sea and I think in the Caribbean Sea that are actually doing well with warming. So what are the genetic differences between the corals that are suffering and the corals that are doing okay with warming? So these are the kind of questions one has to answer. Sahel, can it become completely desertified? 9,000 years ago to 6,000 years ago, there was greening of the Sahara because the precession forcing actually created monsoonal changes, which made heavy rain over here for several centuries and created a greener Sahara, and people moved away from the Nile basin to colonize much of Western Africa, and then when the rains disappeared, they all moved back, and probably some civilizations disappeared. There are alpine glaciers. Indian summer monsoon is supposed to be having a tipping point. Is it possible? Problem I would have is that the uncertainties are very high, and we cannot always say for sure if they will happen, when they will happen, and how likely they are in terms of the probabilities in the scenarios of warming we are expecting now with the emission rates we are on. But nonetheless, we obviously must be very careful about what are hidden in the system in terms of irreversible or no analog states, switches, thresholds, tipping points, and whatever the nomenclature you want to use.